before the first trees rose into the sky, before the first animals swam through the oceans or walked on land, before the first heartbeat ever echoed through the wilderness. There was a world without air, a world where nothing could breathe, nothing could burn, nothing could move with the energy life needs. This was a world wrapped in toxic gases, raging storms, violent volcanoes, and endless darkness beneath the waves. A world that looked more like an alien planet than the Earth we know. 4.5 billion years ago, the Earth was young, unstable, and dangerous. Lava oozed from cracks in the crust. Asteroids slammed into the surface. Thick clouds of methane, carbon dioxide, ammonia, and sulfur choked the sky. Lightning storms raged for thousands of years at a time. The oceans were hot, acidic, and green, filled with dissolved metals. And in this planet's early atmosphere, which felt more like a poison chamber than air, one element was completely missing: oxygen. The Earth was silent, breathless, empty of everything we now consider normal about life. But beneath those early oceans, under the storms and toxic skies, life was already trying to exist. Not the life we know today, not plants, not animals, not anything with organs, eyes, or movement. The first life was tiny, fragile, microscopic. Single cells drifting through the water like dust. Creatures so small that billions of them could fit on your fingertip. And among these ancient microbes was a group destined to transform the planet forever: cyanobacteria. These organisms had no brains, no thoughts, and no idea what they were about to unleash. They drifted near the ocean's surface, absorbing sunlight. But inside their simple structures, an extraordinary process was taking place: the invention of photosynthesis. They learned to use sunlight, water, and carbon dioxide to create energy. And in doing so, they released a molecule the world had never seen before: oxygen. At first, nothing changed. The oxygen didn't rise into the sky, it didn't form air. It didn't spread across the world, it simply vanished. Every molecule they produced was swallowed instantly by the environment. The oceans were full of dissolved iron, giving them a thick green color. And oxygen is hungry. The moment it touched this iron, it fused with it, forming rust. This rust sank to the ocean floor, piling up over millions of years into massive layers that still exist today. These rust layers, known as banded iron formations, are like ancient signatures, proof of the moment Earth first learned to breathe. Cyanobacteria continued their work for millions of years. They released oxygen day after day, year after year, generation after generation. They didn't speed up. They didn't slow down. They simply lived, and in doing so, they filled the planet with more oxygen than the oceans could handle. Eventually, the iron ran out. The oceans were fully rusted. And for the first time in Earth's history, free oxygen escaped. It slipped out of the ocean and drifted upward. And then, the sky began to change. What happened next is known as the Great Oxygenation Event, one of the most dramatic turning points in the history of the Earth. To modern life, oxygen is the element of survival. To early life, oxygen was toxic, it was deadly. Almost every living organism on Earth was adapted to an oxygen-free world. When oxygen began to fill the air and water, it poisoned the very creatures that created it. Massive ecosystems of ancient microbes died off. A wave of extinction swept across the planet. It was the first mass extinction Earth ever experienced. Not caused by an asteroid, not caused by volcanoes, but caused by tiny bacteria accidentally releasing their own deadly waste. But destruction is only half the story. While oxygen devastated old forms of life, it created possibilities for new ones. Oxygen formed the ozone layer, a thin protective shield around the Earth that blocked dangerous ultraviolet radiation. For the first time, life could safely explore shallower waters. For the first time, life could spread. Oxygen also unlocked enormous amounts of energy. With oxygen, cells could fuel far more complex biological processes. They could grow larger, they could specialize, they could join together, and eventually they could form multicellular life. This was the beginning of complexity, the first steps toward plants, animals, and ultimately humans. For hundreds of millions of years, oxygen levels rose slowly and unpredictably. The Earth went through cycles of freezing and warming. The atmosphere thickened and thinned. Ice sheets grew, covering nearly the entire planet in what scientists call snowball Earth. But even in these frozen periods, photosynthetic life continued. Oxygen continued accumulating. And slowly, the Earth transformed into a world capable of supporting vibrant ecosystems. Then came the Cambrian explosion, a sudden burst of evolution where life diversified into countless forms. Shells, bones, eyes, fins, legs, all of these were made possible because oxygen provided the energy needed to build and maintain them. Oceans filled with strange and beautiful creatures. Plants eventually colonized land, releasing even more oxygen. Forests spread. Animals followed. Fish became amphibians. Amphibians became reptiles. Reptiles gave rise to dinosaurs, birds, and mammals. All of this, every creature, every ecosystem, every evolutionary leap was powered by oxygen. Fast forward to today. The air around you is about 21% oxygen. Every breath you take enters your bloodstream, feeding your cells the power they need to move, think, grow, and survive. Your muscles contract because of oxygen. Your brain fires electrical signals because of oxygen. Your heart beats because of oxygen. You are alive because ancient bacteria once changed a hostile planet into a living world. And here's the surprising truth. Most of the oxygen you breathe today is not produced by trees. It comes from the ocean. Tiny plankton and microscopic algae, distant descendants of the first cyanobacteria, produce the majority of the planet's oxygen. The same process that reshaped the Earth billions of years ago still continues every second in every wave under every ray of sunlight. The oxygen in your lungs right now is ancient. It is recycled. It has passed through oceans, rocks, plants, animals, and countless breaths over billions of years. You are inhaling the legacy of Earth's first breath. Without those tiny, simple organisms drifting in ancient seas, there would be no humans, no animals, no planets filled with forests, no civilizations, no stories. Life as we know it, every heartbeat, every step, every spark of thought, began with a molecule that didn't even exist at the start. A molecule that rusted a planet, destroyed entire worlds of early life, and made space for everything that would come next. Oxygen is not just air, it is history, it is evolution. It is the breath that built the world. And now, every time you inhale, remember, you are breathing the most powerful story in the history of the Earth, the story of how life created the very air that life depends on. If you enjoyed this journey into our planet's deep past, make sure you like the video, leave a comment, and subscribe for more cinematic explorations of the mysteries that shaped our world. The story of oxygen is just one chapter in the incredible saga of life on Earth. Thanks for watching.